been deep in conversation with a powerful AI, you ask it a really tough question, and then you just sit there watching that blinking cursor? It's so frustrating. Well, that delay, it's not just annoying, it's one of the biggest roadblocks in all of AI. Today, we're going to dive into a potential solution from NVIDIA called Jet-Nemotron, an approach that might just shatter the old rule that you have to choose between a smart AI and a fast one. So let's get right to the heart of the problem. This is what I call the AI speed dilemma. We've all felt it. You give an AI a giant document to summarize or a complex coding problem, and the whole thing just grinds to a halt. This isn't just a minor inconvenience. It's a massive barrier, holding back what AI can really do for us. So what's really going on here? Why is it that the smartest, most capable AI models on the planet feel like they're running through molasses and cost an absolute fortune to operate, especially when you really start pushing them with long conversations or big projects? Well, for years, AI developers have been stuck with a really tough choice. On one side, you have these full attention models. They're brilliant, super accurate, but they are painfully slow and expensive. On the other side, you've got linear attention models. They're lightning fast and way cheaper, but, they're just not as smart. You had to pick brains or speed. You couldn't have both. The nerdy reason for this is something called quadratic complexity, but here's what that actually means in simple terms. If you double the amount of text you give an AI, the work it has to do doesn't just double. It quadruples. And if you double it again, it quadruples again. It's a brutal exponential curve that acts like a giant bottleneck, making truly long conversations with AI incredibly expensive and slow. But what if you didn't have to make that choice anymore? What if you could just break that trade-off completely? That's the promise of this new research from NVIDIA. So let's take a look at how they pulled it off. Just look at that number, 47 times. That's not a typo. That is the insane speed up in what's called generation throughput that their new model, Jet-Nemotron, gets over a leading competitor. And here's the kicker. They claim they did it without losing accuracy. In fact, they say it sometimes gets even better. And this chart really puts it into perspective. That bar on the left, that's a really solid, comparable model. And the bar on the right is Jet-Nemotron. I mean, it's not even close. But look, faster is one thing. Usually faster means dumber, right? You're making a sacrifice. Well, that's where this story gets really interesting. So, how in the world did they achieve this? What's the secret sauce? Well, it turns out the answer wasn't to build a giant, brand new model from scratch. Instead, they used a super clever re-engineering process they call PostNAS. Let me paint a picture for you. Training a new large language model from zero is like designing an F1 car from a blank sheet of paper. It costs a fortune and takes forever. The PostNAS method is totally different. It's like taking last year's championship-winning car, keeping the ridiculously powerful engine, and then obsessively re-engineering everything else, the chassis, the aerodynamics, to make it lighter and way, way faster. You get a better car for a fraction of the cost. It's just smarter engineering. And it breaks down into 4 really clever steps. First, keep the engine. They take a powerful existing model and they freeze its core brain power. Then, step 2, find the best parts. They basically go shopping, testing all the best high-speed components that already exist. Third, and this is key, they invent new tech. They design a totally new, super efficient part they call the jet block. And finally, they tune for the track. They optimize the whole system to be as fast as possible on the actual hardware it's going to run on. And during this process, they had a huge aha moment. For a long time, pretty much everyone thought the main thing slowing models down was just the sheer number of parameters. But this research found the real culprit, the true bottleneck, was the model's memory usage, specifically something called the KV cache. By finding the real problem, they could focus all their energy on fixing it, and that unlocked these incredible gains. Okay, the theory sounds great, the S1 analogy is cool, but talk is cheap, right? Does it actually work? Well, the researchers threw Jet-Nemotron into the ring against top models on a whole bunch of really hard tests. Let's see the scorecards. Now check this out, because this is the part that really blew my mind. When it comes to tough math and logic problems, Jet-Nemotron didn't just run 47 times faster, it was more than 7 percentage points more accurate. Let me say that again. It's not just faster, it's actually smarter at math. That's not supposed to happen. And it's the same story with writing code. Now, okay, the lead isn't quite as massive here, but it's still winning. It's still more accurate while being ridiculously faster. That's the whole point.
It proves that you don't have to sacrifice quality on these super technical tasks just to get more speed.
So you get the picture. The strong performance in math and coding, that wasn't a fluke. This thing is an all-rounder. The research shows it holds up and often comes out on top across 6 totally different areas, from common sense reasoning to understanding super long documents. It's not a one-trick pony, it's the whole shebang.
So this is way more than just getting quicker answers from a chatbot. A breakthrough this big could totally change where and how we use AI in our daily lives. Let's really think about what a future with this kind of tech could look like. What's so exciting is that this kind of efficiency means powerful AI doesn't have to live in some giant, faraway data center anymore. It can live right here with us on small, local devices, what we call edge devices. We're talking about running it on things like the NVIDIA Jet-Nemotron and getting a nearly 9x speedup. Think about what that unlocks. A surgeon's assistant right in the operating room, or a financial analyst tool that works instantly on their laptop with no internet needed. It's a game changer. You know, to really get how big a deal this is, you have to see where it fits in the story of AI. Back in 2017, the transformer model was amazing, but it had that huge speed bottleneck. Then we got faster models, but they weren't as smart. Recently, we've had hybrids trying to find a balance. Jet-Nemotron feels like something new. It feels like the moment we might have finally figured out how to get both smarter and faster without any compromise. This really does open up a whole new frontier. So I want to leave you with this question to think about. What new ideas, what new discoveries, what new art could you create if the most powerful AI was no longer a slow, expensive tool, but something instant, cheap, and available everywhere for everyone?